reality.
We are.
We live in the outer atmosphere of this magnificent, dynamic, magnetically variable star that dominates every cubic inch of space in our solar system. And if I can get the video, what you would see in the video is that the sun produces storms that can be all engulfing, generating this environment called space weather. The inner edge of the corona that you see that's black in the video is because the sun is so intense that it overwhelms the dim brightness of the corona. And so even from space, we can't absorb the inner part of the corona. And not only Earth, but the entire solar system, as you can see, lives with this dynamic star. Corona is the region where space weather is born and conditions are set for a supersonic solar wind and a super hot corona, two of our outstanding questions in heliophysics, in physics, really. To understand the corona better, NASA is actually going to be launching a mission next year, almost a year from now, how coincidental, called Parker Solar Probe. It is actually going to go touch the sun, and it's going to get closer to any other spacecraft has gone before to the sun to study the corona, to actually sample the very corona that we will be seeing very soon.
Yes, we will. It's almost here. Thank you, Lika, for joining us, and thank you for sharing that. So now we're going to take it back to NASA Eclipse Central in Charleston. Take it away, Dwayne.
Okay, just now coming in, we have an exclusive sneak peek of the total solar eclipse as it is arriving at the United States. It's over the Pacific Ocean and about to reach Oregon. This is the celestial event that we've all been waiting and anticipating for years. We'll begin looking through the eyes of NASA out the window of our G3 aircraft. Let's take in the view.
Wow.
And now we're looking at the first glimpse of the total eclipse from the ground. Wait, let's see. That's still the G3. There we go. And now we're looking at the first glimpse of the total eclipse from the ground on United States soil. This is coming to us from Salem, Oregon, where thousands of people are gathered and experiencing this monumental event, a total solar eclipse. Let's take a look and take in the view.
Oh my God, that's so pretty.
That's the G3 there. Is that the real thing? Is that the real?
It's amazing.
We're going to keep that up, and then we're going to do reactions. Okay, so
as the moon has now moved, the sun is appearing again, and we can see the diamond ring. It's amazing. It's fantastic. You see the outer edge. I see prominences, little red pieces of chromosphere from the lower atmosphere. This is amazing. This is absolutely amazing.
Jody, what we got? That looks pretty cool.
I mean, it's breathtaking. I just, even seeing it right now through the TV, it's just an amazing thing to see. I cannot imagine what we're going to feel here in South Carolina when we have our chance.
Well, I hope we have our chance to, you know, Sean, and, you know, get that weather up here looking good here in Charleston. Now, what do we...
So, Alex...
Alex, what are we seeing here?
Is that from the G3? That looks like from the G3 because I see spectra there.
No, it's still from Salem.
That's still from Salem. Yeah. Okay, so you're seeing the bright... Actually, the camera is causing a little prism effect there, and you're seeing the bright light from the edge of the sun. So that is really beautiful. That's sort of the edge of the diamond ring effect.
Yeah.
So, Alex, now, a reminder, Alex, so when that diamond ring pops up, that's when people should put the
That's when people should put your glasses back on. So when you see that diamond ring after totality, that's the signal to you that it's time to put it back on. Yeah. So look now, we see the corona in Madras. That's gorgeous.
That's amazing. I mean, being able to look at that with your own eyes is an amazing experience. And that only can be seen when you have this kind of totality.
So the corona, that's the
solar atmosphere.
That's what solar scientists really live for, right?
Right. Right. That is the origin. That is where the origin of space weather.
Yeah.
You know, that's where it comes from.
That's where most of the solar flares and the corona mass ejections, big explosions of particles, originate from.
Now, if there was solar activity, would we see it right now? Would we be able to see that popping up on the sun?
If there was a coronal mass ejection leaving the sun, we could see it there because, in fact, we have seen it in the past, and I'll even show some history later with images that people drew of these coronal mass ejections leaving the sun during a total solar eclipse.
Now, why is it so critical and so important to really get this type of view from the sun's atmosphere from the corona? Johnny?
You mean like in a total solar eclipse?
Yes. There's the diamond.
That's the diamond ring again. That's amazing. That's from Madras.
Wow.
It is important to do this because we do this kind of eclipses artificially, but we do not do it as perfect as nature does. The moon covers the sun in such a perfect way that we see parts of the corona that we don't usually see.
So Alex, explain that and safety too, right?
So right now, this was the moment when you see that flash of light. That's the moment when it's time to put your glasses back on or start using your indirect methods because now it's too bright and it could damage your eyes.
Yeah. Safety first, people. Always.
Wow. So the folks in Salem, Oregon, I mean, they're like juiced. I mean, they got it. They got the good.
They've got a perfect view, and they are seeing one of nature's most amazing spectacles.
I can only imagine the reaction on the ground from the folks there.
Oh, they are probably
gasping.
Completely overwhelmed right now. Completely overwhelmed.
Well, I certainly hope we get something like that. But we've got it here on NASA television through the eyes of NASA. And we got the International Space Station coming up and other images only we can bring.
Only NASA can bring, yes.
Now, is it completely dark or is it coming out?
No, what's happening now is the filters are back on, the safe solar filters for the telescope, and now you see the crescent, which is the sun, basically now being revealed after the eclipse. So we're now back to the partial phase in the other direction.
Exactly.
Now, how fast is this going?
Well, this shadow is passing across the country, depending on where you are, anywhere from 1,200 to 1,800 miles an hour. So this is moving incredibly fast because the moon itself, in its orbit, is moving at almost 3,400 miles an hour. And that, in combination with the rotation of the Earth, is what gives us a shadow moving that fast.
Okay, so Gotti, let's talk about space weather. Seeing this and space weather is so important. So just let us really understand why it's important on space weather.
So space weather is pretty much the conditions created outside in space due to the sun. We look at space weather because we want to understand these conditions. If you look at the image that you have now, you're going to see SDO image, the Solar Dynamic Observatory. That's where we actually look for the source of space weather, where the solar flares and the coronal mass ejections actually originate from. Well, when we look at SDO, at the images, we also have to look at artificial eclipses, like the one that you're looking at online now. These are actually from the SOHO spacecraft. These are the artificial eclipses that I was talking about, Dwayne. Like this, you have to block the solar surface to be able to see the solar atmosphere, the outside corona. But you're gonna see something like this today, and you saw it. But you're gonna see it better because nature does it better than we can actually do it artificially. Right now, the activity is not, there's not too much going on in the sun. However, if I do a historic event, which actually was from this past July, you can see a coronal mass ejection, this big explosion of particles that come from the sun.
Well, those look pretty intense. Do we have to worry about that? That doesn't look good.
Well, you know, space weather, what can actually do is affect communications. We have the magnetic field of the Earth to actually protect us. It's our shield. And what we do is we actually can analyze that using real-time models like the one that you're seeing on the screen, that we actually understand how the magnetic field of the Earth changes with those coronal mass ejections. But space weather can affect communications, satellite instruments, and power grids.
Okay, so we're going to toss to Idaho. And I think we've really got some good stuff here. Gay Hill, are you there in Idaho Falls? Idaho Falls?
I am absolutely here, Dwayne Brown. In fact, looking through the glasses right now, it's so weird. We have a crescent sun instead of a crescent moon. This is the, I think we haven't had a total eclipse here in Idaho Falls since 1889, 128 years ago. And things have certainly changed in Idaho Falls since then. There's a whole lot more people, especially with all the visitors in town. We're just outside the Museum of Idaho, and we have partnered with the museum to make this an official viewing site for Idaho. And they right now have an exhibit on space, but we also sent in a team of experts. And for the past 3 days, we've had talks, we've had demonstrations, we've shown them visualizations such as eyes on the solar system, and we've shown them artwork. But really, the order of the day is the eclipse, and NASA has that covered too. They have sent an army of volunteers. We call them solar system ambassadors. They are all along the path of totality, and they're volunteers. These are people just telling people what they're seeing and helping them understand. We have one here, right here. His name is Richard Stember. Hey, Richard. He has been manning this mobile observatory, and that is what is providing our solar telescope shot right now. Now, we asked him, what's it like being a solar system ambassador? And he said, follow along. We did, and we went with him to a place, a school in Southern California. Take a look. All right, we apologize. There is no audio on that video, but it talks about the solar system ambassadors. There are about 720 in the United States. They get special training from NASA. They learn all about the missions and about the science, and they basically go out to public events all over the country teaching them about NASA missions. If you would be interested in becoming a solar system ambassador yourself, you can. We have a website. Look it up. up Solar System Ambassadors. It is a NASA website, and starting September 1 through the end of the month, you can sign up to be a Solar System Ambassador. So check it out on the web, Solar System Ambassador. With me now is Jim Green. Jim Green is the head of planetary science for NASA. He's in charge of all planetary missions and asteroids. This guy knows his stuff. Let's talk about this. Now, you see this eclipse that doesn't happen. It happens once in a lifetime.
Wow.
But as a scientist, you see it as an opportunity.
Oh, absolutely. I mean, we're getting the eerie feeling right now, but when we launch balloons, and there'll be 57 balloons along the path, 30 of which are going to have a planetary experiment on them.
And we have video of this. Now, just a few days ago, we had a crew here. They did a test launch for us, and they sent up an imaginary payload for us just to see how it all works. You have actual scientific experiments going up.
We do. We have a bacillus. It's a harmless bacteria. We have on 30 balloons 2 coupons where the bacteria will be sprayed. One will stay on the ground, one will be affixed to the balloon. It then will go up to 100,000 feet above the ozone. So the ultraviolet light, also blocked a little bit by the moon, is just like Mars. In addition to that, the temperature and pressure will be just like Mars. So when the balloon goes up higher and bursts, comes down, we'll retrieve that coupon off the balloon, match it with the one on the ground, and then we'll see how many survive.
Now, why is that information so critical for Mars research?
Well, this bacteria is pretty much everywhere. It's very hardy, and it probably has made its way to Mars, perhaps even on our rovers. And I would like to know if that environment is so harsh that it would eliminate that bacteria or not.
All right. I'm being selfish. I have never seen a total eclipse. And I'm sorry, I would love to talk to all of you people, but I want to put on my glasses too and take a look. Can we continue this conversation?
I have to do this too.
All right, and watch, and we can talk. All right, so
what
we
a little sliver.
Just a little sliver of the sun right now. And let's talk about this. Why is this so rare?
Well, you know, the plane of the moon relative to the Earth-Sun line is tilted by 5 degrees, and so there's only 2 places where the moon and the Earth and Sun are on that same line, and that's why every 18 months or so we get an eclipse.
The shadow is 1 minute.
1 minute away. Wow.
Crowd is getting excited.
Wow. It's already so eerie.
Oh, wow, it just got dark all around us. And you can feel the temperature getting colder here.
Oh, yeah. The winds are really picking up. You know, this dark area, the winds are just flowing in.
Oh, you can, it's just a tiny, tiny sliver right now. It's all closing up.
There it goes. It's going. Getting smaller.
Oh my gosh!
Oh, look at the ray structure. You can't get that on film. There's Venus.
Oh wow!
There's Venus. Oh, wow. Wow. Oh, look at that ray structure.
You were saying this is the only way you can see the atmosphere.
Yeah, that lower part of the corona is really even hard from space to see. Wow. Wow. I got to spend a second looking around at the crowd. Oh my goodness. Yeah, wow. Wow.
We should turn off the lights.
get ready to put them back on here soon.
Okay.
Pretty quick.
Have you noticed, Jim? The street lights are all on around
The street
us.
lights turned on,
We
of course.
confused the street lights.
Of course. Who would have thought that? We didn't plan that one.
All right, we should get ready for our glasses again. Get ready with your glasses.
Okay, there it goes. There's the
Stand by.
diamond ring. There's the diamond ring.
Oh my gosh.
Yeah, wow.
That is
Was
so...
that all right?
Oh my gosh. Whoa! Oh, that's brilliant.
All right. Wow.
Okay, glasses back on.
Wow. Too brief. Too brief. Too brief.
Okay. We're going to have to wrap this up pretty soon, Jim. That was incredible.
Way too brief.
Yeah.
Way too brief.
We got a minute 50 seconds.
Yeah.
That was all we had. Why is it that some parts of the country get a little more than we do?
Well, it has to do with the curvature of the Earth also. And so the shadow is at various altitudes. You could go up at a higher altitude and get also a great view too.
Well, this was a real treat. This was fantastic. So Idaho Falls has had its total eclipse. The next one is coming in 2252. We won't be here, but we hope NASA will. Back to you.
Well, Gay Hill, that's Gay Hill from NASA's Jet Propulsion Laboratory. Gay, I'm jealous. I'm telling you, I'm jealous. So, Alex, explain again that diamond.
Well, so the last bit of sunlight, when you see it at the very beginning, is when the last bit of the sun, the crescent, shrinks down to a little tiny bit. And at the same time, you can see a ring of the corona around it, so that makes the ring, and then that bright bit of crescent gives you the diamond. So when it reappears, you get the same thing. The last bit of corona is a ring. The flash of the sun is the diamond, giving you the diamond ring. It's a beautiful, beautiful sight.
And real quick, and then I'm going to ask you a question because there was something going on here in Charleston. The planetary, Jim Green said something about Venus. This is really cool for planetary science because you can see other planets, right?
Absolutely, and as a matter of fact, one of our missions through the WB-57 aircraft are studying Mercury, which is very, very close to the sun.
Okay, so we're gonna come back to you and we're gonna talk about what's happening here. So the next up, NASA is ready to take a bite out of the Big Apple, one of my favorite cities, Jody, New York City. New York City. Today's broadcast is being shown, I believe, in Times Square on the Toshiba Vision screen, so the city can also enjoy the spectacular views of today's total eclipse. And we've got a great relationship with Toshiba, so a shout out to you guys. This Midtown Manhattan tourist location is always bustling with crowds. On the average day, over 300,000 people pass through Times Square. Alex, I'm gonna turn to you. You know, New York, they're gonna get a partial, but they have a rich history in solar eclipse.
They really do. So actually 92 years ago, on a cold January morning, New York City, Manhattan, and Queens experienced a total solar eclipse. The edge of the path of totality went from 95th Street to 97th Street. This was an amazing opportunity. This was the first time we sent up 2 dirigibles with the U.S. Naval Service for scientists to study this. At the time, we actually thought eclipses could be creating radio waves which mess with communication. But what in fact is happening is the sun itself is creating this disturbance. So studying the eclipse is actually telling us about the sun, which is creating these disturbances here on Earth.
Yes.
Okay, so this just in. I believe we have results from an experiment that occurred on NASA's Gulfstream 3 aircraft from NASA's Armstrong Flight Research Center. Karen Rohr is standing by with Thomas Zabukin, the Research Administrator for the NASA Science Mission Director. Let's go now to see what the instrument observed during the total solar eclipse. Kevin.
And we're back here at the G3 up over the Pacific Ocean off the coast of Oregon. And it was amazing, wasn't it?
It was outstanding.
And so for me, like, you know, at 25 years, I did research on the corona. I saw it for the first time. It was my first eclipse. Was it your first eclipse?
My first eclipse as well.
Just absolutely amazing. And I want to talk about two things. First of all, the shape of the corona. You know, I saw the models, I showed the model, and it was remarkably similar. You know, I saw these streamers, these magnetic structures coming out like glows in specific directions, just like we expected. So I'll look for the analysis before we claim victory, of course. But the other one is that spectrograph you, Mike, you know, ran on board. And just before that the sun, you know, disappeared behind the moon, that spectrograph, of course, is spreading out the light in all its colors. Just before it disappeared, there is that one shot. And Laurie, I want to ask you whether you can turn it on. Do you see those specific kind of lines that pop up between the green and the red? It's just like we said, it's helium. Remember, that's how it was discovered, helium. We didn't know we had helium here. It was a new element. It was discovered that way. And then over there in the red, between the green and the red, is iron. Iron, a really hot iron, telling us that, hey, this atmosphere is really hot. And then a little bit over, it's another line, red. Well, what is that? Well, it's hydrogen. Well, so even though it's really hot up there and only 1 in a million or 10 of million particles are neutral, it's still visible in that one shot that you saw. So Robert, back to you here, back on Earth. What did you feel like? How did you see this occur?
Yeah, so it was fascinating to watch actually the shadow or the path of totality underneath us. We're at 35,000 feet, and you could see at totality, you could actually see the darkness down on the ground. And you could look north and south and see where it wasn't completely dark. And as we kept going, you could just watch that darkness move. It was almost like a thunderstorm moving across the plains, but it was all the darkness, and it was just stunning to me to see that. So really, really good stuff, and I wasn't expecting that. And of course, the eclipse itself was beautiful, but seeing what happened down on the ground level of Earth from 35,000 feet was amazing. I just got to tell you, the team on this plane and the team all the way around this country is just doing a fantastic job. I wish you could have seen the folks here working to make sure we got the data that Thomas showed, some fantastic images we've already looked at that I can't wait to share with everybody and for everybody to see. But really exciting to watch this team work, and the pilots did a great job. We had a little bit of a challenge right at the time of when we needed to be best, but they did a great job recovering from that, and then kept us on path all the way through. So anyway, so thank you guys. Remember to put your glasses on for those of you who hadn't seen it yet, and we'll talk to you soon.
Fantastic stuff. And if you just tuned in here, you're watching Through the Eyes of NASA, NASA television. We have the best views of the solar eclipse today and coming later in the show. You don't want to miss this, the International Space Station live. Now, next up, let's visit a working farm at Austin Peay State University in Clarksville, Tennessee. Agricultural observations and solar eclipse viewing activities are underway, including high-altitude balloon launches and painting cows.
Painting cows? What?
Okay, all right. So now let's go to the NASA Marshall Space Flight Center. Chris Blair standing by.
Well, humans are naturally excited about the solar eclipse, but one thing we've learned on this working agricultural farm is that animals can as well. But more on that in a moment, as right now we're getting ready to do a live scientific balloon launch. And joining us to tell us
ese viento que sentimos en el momento de la sombra, si bien son 2 o 3 minutos, se siente el bajón de temperatura en el aire.
Claro.
Si fuese solo en la Tierra, quizás no afectaría tanto a la atmósfera, pero que el aire cambie tanto de temperatura, casi 7 grados, debe generar corrientes, lo que la gente llama microclima. Bueno, acá me parece que se dio algo de eso por momentos, pero va a ser un tema lindo para charlar con Matías y con toda la gente de la facultad, ¿no? De la UBA, que seguramente tenga alguna teoría al respecto, más allá de que acabo de idear yo. Mira, 21 grados. Mientras empezamos a hablar, subió casi 1 grado la temperatura.
Estás volviendo a la normalidad, José.
Recién estaba en 20, ¿vieron cuando le mostré?
Sí.
Estamos volviendo y vamos a volver seguramente a los 29 o 30 grados. No miré el pronóstico, no lo miré, le quiero decir a Matías. Él se deleitó porque estaba allá. Yo cuando pisé suelo norteamericano, borré todas las aplicaciones, todo lo que usamos para hacer pronósticos, lo borré. No lo quiero ni ver.
Está muy
Sabía
bien.
que veníamos a este lugar y al que no vio la explicación al principio le decimos, estamos en esta zona, no para darle la recibida al eclipse, que fue lo que hicimos, sino porque esta era la que generalmente tiene menos nubes. En Argentina, si hubiese que elegir un lugar, y tuviésemos que elegir cualquiera, elegiríamos San Juan, Mendoza, Neuquén, como los lugares, La Rioja, como los lugares con menos nubes a lo largo del año.
Donde tenías más probabilidades de verlo bien.
Fuerte, que es que vos tenés que ir... Exacto, Flor. Pero acá uno no puede elegir libremente. Tiene que elegir solo a lo largo de una línea. Es decir, la línea de sombra de la luna, bueno, a ver, desde Pacífico hasta el Atlántico, ¿en cuál hay menos probabilidad de ver nubes? Bueno, en esa, y nos movemos. Así que por eso estamos acá en Madras y no nos falló. La estadística se cumplió y por suerte la chance de nube fue baja y se cumplió esa parte del pronóstico.
Bien, José.
21 grados.
A ver, ¿cuánto?
Sí.
No, ¿cuánto ahora?
21 grados 4.
Y va a seguir subiendo.
21,4, el de arriba, el número chiquitito.
Qué rápido sube, ¿eh?
A ver si llegan a verlo.
Aumenta la radiación.
Bruno está
ahí está, mirá.
Ahí se ve arriba.
Ya casi en 21 y medio, ¿eh? Ahí está, ahí se quedó. 21 y medio.
Sí.
Bueno, José, aguantame un cachito, papi. Aguantame un cachito que quiero hacer una consulta a Marina. Marina, Denver, Colorado.
Sí, están ahí, en cuenta regresiva, 1 minuto y medio para que en Colorado, en Denver precisamente, ocurra el eclipse. Así lo están viviendo en vivo, en esta forma. Ahora seguimos el trayecto de la sombra que hace la luna. Se interpone entre el sol y la tierra y lo vamos siguiendo en vivo por TN. Ya pasó por Oregon, ahora estamos esperando a 1 minuto nada más. En Denver... Escuchamos el ambiente, rapidísimo, súper veloz.
Marina.
Sí.
Recordemos que aquí en Denver se va a ver hasta el 94%.
Es parcial,
podemos 94%, exacto.
Pero igual 94% te diría que es...
Te regalo los 6
alto,
restantes.
¿no? Claro.
Van a ver un pequeño filamento, una pequeña, como estamos viendo ahora, deben quedar segundos nada más.
Queda como una uñita chiquitita.
Apenas, apenas. Lo que le suelen llamar el anillo de diamante.
Ah, mira vos.
Qué lindo nombre.
Son como unos pequeños destellos de luz que se van a ver en esa pequeña franja, en ese gajito. 40 segundos. Ahí tenemos la cuenta regresiva.
A ver, ya llega, ¿eh?
Y vamos a ver un pequeño filamento. Recordamos que en Oregon fue total, fue del 100%.
Sí.
Y ahora vamos a ver la diferencia. Para el ojo humano prácticamente imperceptible, pero a ciencia cierta un pequeño porcentaje. Ahí queda.
Ahí quedó.
Ahí está, ¿eh? Acaba de llegar el eclipse americano a la ciudad de Denver. Es un eclipse parcial, un 93%, ¿no, Maru?
Exacto.
93%, yo te digo 93, para mí es 100.
Pero 93,
Y seguimos el recorrido.
Perfecto.
Muy bien, en Denver, por estas horas, están disfrutando lo que ustedes acaban de disfrutar, con José Bianco en vivo desde Oregon por Todo Noticias, por el Facebook Live de Todo Noticias, por el canal de YouTube de Todo Noticias. Más de 100.000 personas siguiendo la transmisión por los soportes digitales de TN. Bienvenidos, un lujo tenerlos del otro lado.
Bueno, volvemos con José Bianco. Ahora que hemos visto el eclipse en Denver, volvemos con nuestro amigo José. Ahí lo tenemos, ya con la luz del día, con ese sol, ya se fue la sombra. Y
calorcito de nuevo.
¿Y ahora?
23 graditos.
Mirá, qué rápido.
Hasta 26 no parás,
25,
A los 26.
A los 25, sí, pero Mati, a los 25 creo que Chávez va a destapar el festejo, me parece.
¡Epa!
Me parece.
Ah, se llevaron todo. Muy
Qué
bien.
bárbaro, Ricardo.
Hablando de destapar.
Está muy bien, está muy bien.
Creo que guarda con el corcho, no lo tires para acá arriba. Porque en cualquier momento...
El que le toca ahí el corcho se casa, dice la tradición, ¿viste? Se casa.
Estás dando una
va a caer a él.
Y dale, Juana, con la campana.
Pero es la tradición.
Te empujan, te
es la
empujan.
tradición, José, no lo inventé.
Cuidado el telescopio, por favor, pongan a salvo el telescopio.
Eso. Que es caro ese aparato.
Sí.
Mirá, vos te podés dar vuelta para mostrar eso, para que Richard, ¿vos sos amante de los autos?
Sí.
Bueno, ¿cuáles te gustan? ¿Los nuevos, los viejos?
Me gustan los nuevos.
Mira, Bruno, ahí atrás de...
Glasses instead of eclipse glasses, will we actually be able to see the eclipse? The sunglasses help. Does it give you any sort of protection?
No, that's definitely a no-no. You should not wear sunglasses, normal sunglasses. Always wear the actual sunglasses that are made for solar viewing, like the ones that I'm having here right now in my hand. And if you don't have the sunglasses, you never look directly at the sun. You look like you do an indirect projection of that eclipse. Never look at the sun without the proper safety.
So another question here comes from Deborah from Facebook. So the sun rises in the east and sets in the west. And the Earth rotates in clockwise motion. Please explain how it starts in the west and ends in the east.
Well, so the Earth is rotating from west to east, but actually the moon is moving faster, about 3,400 miles an hour, casting a shadow down on the Earth, which is rotating about 1,700 miles an hour. And that actually means that the shadow is moving from west to east across the Earth at about somewhere between 1,200 to 1,800 miles per hour, depending on where you are on the Earth.
Okay, great. We have another one. I think we have time for another one. Tina from Facebook's asked, if I place a lens from the eclipse viewing glasses over a viewfinder on my iPad, could I successfully video the eclipse, or would it fry my camera?
Yeah, you can actually look with the iPad or your phone to the eclipse. The only thing is, you have to be very careful not to look at it with your own eyes without the actual safety glasses. Never look at it through any lens.
Okay. This is Mickey from Facebook. Hey, NASA, can the International Space Station see the shadow of the moon crossing America from space? Do they have that view when they're looking from space?
They do, and that's what we're hoping to see from them, yes.
Excellent. So, John, we're going to come back to you. So I think we're going to go back to Sean, our meteorologist. Let's learn more about how NASA is studying the Earth and Sun relationship during this eclipse. Sean, can you tell us more about that?
Right, thanks, Dwayne. So during the eclipse, the moon acts like a giant cloud as it passes over areas in the path of totality, casting a large shadow on Earth's surface. Now, the footage you're seeing right now shows a solar eclipse that occurred in March of 2016 over Indonesia. That experience helped us determine how best to study today's eclipse. These images were taken by NASA's EPIC instrument aboard NOAA's Deep Space Climate Observatory, or DISCOVER. It's just one of the instruments we'll be using today to study the eclipse as we monitor changes in Earth's energy balance. Scientists have made extensive atmospheric measurements during eclipses before, but this is the first opportunity to collect coordinated data from both the ground and from a spacecraft that observes the entire sunlit Earth during an eclipse. Dwayne, back to you.
Thank you, Sean. Okay, so now we have a special guest with us today, the Associate Administrator for NASA's Office of Communication, Jinray Wong. Jinray, welcome.
Dwayne, thank you. So happy to be here.
Oh, it's an exciting day.
I'm
glad you're to join the team here. And our next location you are pretty familiar with, I'm sure.
I'm very blessed, and I do know something about the great state of Nebraska. I've actually lived there for the last decade, and I have friends and family who are watching there from the path of totality. I have to tell you, this is by far the biggest thing that's happened in Nebraska as of recent. It's absolutely fabulous. I have had friends from high school and college calling me up, Facebook messaging me, asking where they can get their glasses, where they should be viewing from. So it's just a really exciting day for everyone who's watching along the path of totality. It's also a really exciting day for NASA. And in fact, this gives us an opportunity to look forward as well. And we have a future study that we are going to be doing for to study the sun. NASA is going to launch a new spacecraft next year, the Parker Solar Probe, and it will fly directly into the solar atmosphere. The mission will provide first of its kind data. And for more information on this future mission, let's go to Beatrice, Nebraska, where Vince Whitfield from NASA's Langley Research Center is standing by. He's at Homestead National Monument, where the National Park Service has coordinated an eclipse viewing. Vince?
And just in, I think we're having, Vince is going to come up shortly, Jinray, so we're going to go back with an image, but we will be doing Nebraska as soon as we can. So a shout out to the great state.
Thank you.
Okay, folks, Jody and Alex, this is a different view here. What are we seeing, Alex?
Well, so we're looking at a different wavelength of visible light. It's called calcium K. So this is light that's produced by excited calcium. And this is showing us the sun as the moon is moving over it. And in fact, if you look over to the left, on the edge of the sun, you actually see sunspots.
A sunspot, yeah.
And these are regions that heliophysicists like myself and Jorshy are most interested in, because that's where solar explosions originate from. In fact, the magnetic fields that come up into the corona that we see during the total solar eclipse originate from those sunspots.
Actually, this sunspot had a solar flare yesterday.
Right, and I believe this is coming from Carbondale. So that's now it's why is it purple? Is that what's the color?
That's actually the light and the color of the light in the filter. The color is a bluish light, and so it comes out as a purple color. But it is a type of visible light. It's one we look at quite often from both space and the ground and look in the sun.
Now I see some black thingies, look like a little river. You see it over there near the corner on the left?
Yeah, that's the sunspots.
Now, what's a sunspot, just for our audience here?
Those are the regions where most of the space weather actually originates, the solar flares, the coronal mass ejections, are regions of the sun that have very complicated magnetic fields. And these are where most of the magnetic energy is actually released.
Right, so those are regions of super intense magnetic field, 1,000 times stronger than the Earth's magnetic field. And those have lots of energy, and they drive space weather.
Okay, I think that's why we didn't get the Nebraska feed right now. Those things cause that, I think, right?
That's right. We're getting a little glitch.
Hopefully we get Nebraska. Okay, Sean, we're going back over to you. We'll talk about moon shattering.
That's right, Dwayne. We've got some really incredible imagery for you. This is again from the GOES-16 weather satellite, just launched last year by NASA for our friends at NOAA. And what you're seeing in the western portion of this image is actually the moon's shadow being cast over parts of the path of totality. And of course, you see the cloud cover across the U.S. as well. And as I was telling you earlier, it's actually looking pretty good for most of the western parts of the U.S. that are in the path of totality. Not so good for maybe parts of the central U.S.
En estos 99 años ha avanzado de sobremanera y nos permite tener estas imágenes tan preciosas como estamos transmitiendo en este momento en vivo por la pantalla de tele.
Ya se está retirando, ¿no?
De a poco, de a poco. Nosotros decimos de a poco, en realidad es una velocidad altísima, más de 3.000 kilómetros por hora, pero visualmente todo el episodio, desde que comienza el sol a avanzar, la luna, la sombra de la luna, avanzar sobre el disco solar, tarda 1 hora y media aproximadamente todo ese proceso. Recordamos que nosotros comenzamos la transmisión especial a la 1 de la tarde, son casi las 3 de la tarde, seguimos viendo el avance de esta sombra que va a terminar de cubrir parte del océano Atlántico. Después de que suelte a Carolina del Sur el último pedacito de superficie de los Estados Unidos, va a comenzar a adentrarse en el océano Atlántico cuando finalmente se pierda allí.
Marina,
sí.
Está Matías. Matías, contanos.
Estamos siguiendo la trayectoria justamente de la totalidad, ¿sí? Y vamos recibiendo toda la información y ahora vamos a ver, pues justo se nos nubló. Ahí viene de vuelta porque hay nubes. Estamos en el estado de Illinois, en Carbondale, ¿sí? Es en el sur del estado de Illinois, donde sí se va a ver total. Sí, esta zona sí va a alcanzar la totalidad, va a tener que pelear con las nubes. Ve que aparece y desaparece, aparece y desaparece porque está compitiendo contra la nubosidad que hay justamente en la zona. Pero en un ratito le falta todavía, unos 20 minutos, en un ratito en esa zona y en un ratito también en perdón, lo voy a decir bien, en Nashville, así, Nashville, en el estado de Tennessee, también vamos a estar en vivo porque por ahí va a cruzar la totalidad. Son las próximas 2 que vamos a estar siguiendo para mostrarles a ustedes. Si se perdieron hace un ratito lo que vimos en vivo con José desde ahí, desde Madras, en el estado de Oregon, lo van a poder seguir viendo, porque el gran eclipse americano, que lo seguís en el gran eclipse en TN a través de las redes sociales, sigue y te lo mostramos en vivo, chicos.
José Bianco, te escuchamos.
Estoy ahora sí cayendo un poco con lo que fue esta transmisión, con lo que es es esta transmisión, pero acá es inevitable sentir que estamos bajando de un pico de emoción. Así que ustedes sepan que esto se sigue dando sobre los Estados Unidos y que viene la parte del país más poblada, una de las costas más pobladas del mundo, como es la costa este de los Estados Unidos, y más allá de alguna nube, ha sido un día en general bueno para el país en cuanto a lo meteorológico, porque algunos pocos lugares se lo van a perder, pero en términos generales son menos de la media, ¿está bien? Así que por ahora, disfrutando. Yo no sé, Matías, si vos me corregirás,
a ver,
tuviste más tiempo para chequearlo, pero nos estaban viendo en el Facebook más de 140.000 personas en un momento.
A la vez, exactamente.
Increíble.
En el momento en que vos, en el que se hizo de noche, que en un ratito lo vamos a repasar, porque como teníamos la duda con Ricardo, fue de golpe nomás, ¿sí? Y vos lo viviste, que fue de golpe, en unos 20 segundos. Esta es la imagen que estamos recibiendo ahora de la zona de donde estás vos, de Madras, cómo el sol le va ganando a la luna y se va recuperando por completo. Y les cuento algo, ¿ven esas manchitas negras que se ven en el centro de la pantalla? Acá nos decían los chicos que nos están acompañando y ayudando, Ariel y Edgardo, que son manchas solares, que eran muy claras en la mañana de hoy y que se ven muy claras en la imagen. ¿Ven esas manchas negras? Eran manchas solares. Sí.
Vamos a ver una foto. Acá nos dice Maxi,
a Ariel
el
Cachuca,
productor.
que siempre también nos da...
unos genios, están acá los dos.
¿Hay una foto?
Ah, mira.
Bueno, que siempre nos da una mano.
¿Quién?
Ariel y Pablo, los
Ariel
dos.
y Pablo.
Vos, cuando nos separamos, vos y yo, ellos andan atrás nuestro, hoy al lado nuestro, y en muchos casos estuvieron por encima en cuanto a las tareas que tuvieron que llevar adelante, pero seguramente ellos te sepan decir que las manchitas esas que vemos son de un tamaño mayor que la Tierra.
Exacto.
O sea, la Tierra entraría en esas manchitas, como le decimos, y eso te da una magnitud de lo gigante que es el Sol. Y recién Ricardo hablaba de la corona solar. Recuerden que el Sol es un bicho raro realmente, ¿eh? Es una bola de gas prendida a fuego con estas explosiones internas que son las que permiten la vida en nuestro planeta, pero por momentos se le va la mano a las explosiones y parte de la masa sale eyectada del Sol y viaja hacia todo el sistema solar. Recuerden ustedes que hay lo que se llama viento solar, es decir, partículas del Sol que continuamente salen del Sol y viajan muy, muy lejos y hacen que, por ejemplo, ese avance continuo de las partículas hacen que los planetas giren todos en el mismo sentido. Y que también hacen que, por ejemplo, cuando un cometa se acerca al Sol, su cola... también el rastro que va dejando sea desplazado hacia un sentido en particular. Es decir, el Sol está continuamente emitiendo material a medida que va aumentando su edad, va madurando. Sepan que nuestra estrella en una persona tendría cerca de 40 años, para que lo entiendan. Casi la edad de Chávez, nuestro camarógrafo, aunque parezca de más. Pero digo, 40 años... Para una estrella es una edad, es la madurez, está todavía liberando mucha energía, quédense tranquilos, quedan todavía por delante más de 4.000, 5.000 millones de años con facilidad, pero atentos porque esas eyecciones de masa coronal, esas expulsiones de material, han generado apagones muy, muy grandes y yo creo que podrían generar una de las crisis más complicadas en el caso de darse alguna explosión de las complicadas, pero no a la vida humana en sí, no como cuestión biológica, sino como cuestión social. Ha pasado hace cerca de 40, 50 años un gran apagón en todos los Estados Unidos, en parte de Canadá, también en Europa, producto de estas explosiones que generaron complicaciones. Imagínense ahora, en una sociedad tan dependiente de las comunicaciones, de los satélites, de todo lo que tiene que ver con lo relacionado a Internet. Las casas están conectadas a Internet en muchos lugares de Norteamérica y de Europa. Bueno, quedarse sin esa comunicación durante 2 o 3 meses, imagínense lo que podría generar en el mundo. O sea que este momento de la totalidad que están viendo a lo largo de todo Estados Unidos, lo que permite es conocer cómo se porta esa corona solar, esa parte más complicada para nosotros. Y sin duda que es bueno que pase por mucha zona de continente, mucha zona continental, porque te permite más tiempo para sacar más fotos. Fíjense que va a ser casi una hora de estudiar el comportamiento del Sol de esta manera que, si bien artificialmente se puede generar, los telescopios que están flotando en el espacio pueden generar un mini eclipse para poder ver la corona solar y no la parte brillante del Sol. Esta es una situación privilegiada para hacerlo y que permite afinar mucho el detalle y da mucho detalle de lo que está pasando con esas... ¿Se llegó a ver, ustedes lo llegaron a ver, la corona solar? Sí. Los rayos del Sol,
sí, fue espectacular.
Cómo tomaban forma a medida que salían del Sol.
Sí, se vio absolutamente.
Ese fue el momento que a mí me va a quedar grabado para siempre.
La verdad que sí, se veía espectacular,
realmente,
se vio, se vio claramente. El momento, sobre todo, cuando allí se hacía de noche. Después, por supuesto, que lo vamos a repasar. Y ustedes saben, Marina, Matías, José, que estaba acá repasando las redes sociales, me metí en el Facebook Live de Todo Noticias y la verdad es increíble. 100.000 personas, todos conectados, y también en el canal de YouTube de Todo Noticias, siguiendo esta transmisión en vivo por el soporte digital de TN. Y ya... vamos a decir las cosas como son.
Dale, dale.
Muy lindo Denver, Oregon. En un ratito vamos a estar con Diego Poggi en la ciudad de Nueva York. Pero acá ya está todo el mundo hablando del 2 de julio de 2019.
Sí, vamos.
Cuando esto mismo, esta franja, pase por Chile, Argentina y pasa por Buenos Aires. Acá ya estamos con eso.
Hacemos una fiesta.
Acá ya,
en serio, pista, no pensamos que iba a pedir. Sí.
¿Quién pide perdón? A ver.
No, José quiere
participar.
José, dale.
Pido pista porque están hablando de un futuro lejano en términos de fenómenos astronómicos.
Y que acá estamos entusiasmados y queremos ser parte.
¿A dónde querés viajar ahora, José, antes?
Queremos ser parte.
¿Nos vas a llevar?
Ahora queremos
escuchame, acá en el país, llévame a mí, ¿Querés ir a San Juan? Llévame a mí.
Bueno.
Ahora queremos, ¿viste?
Bueno,
acá no
tenemos que viajar.
Nos cebamos, ¿viste? Acá nos cebamos y ahora queremos todos que se nos haga de noche, obelisco, qué sé yo. Cada uno de nosotros en un punto distinto de la ciudad.
Matías, capaz que no me... Sí. Bueno,
¿en qué
eso en el 2019. Ahora? Tenemos tiempo para hacerlo, ya lo tenemos ahí a Guille. No, iba a decir que... algo que también me voy a sincerar. A mí me gusta mostrar las cosas como son, puede quedar desprolijo. Nunca ningún jefe nos dijo, che, no muestren eso que queda feo.
Siempre una
y eso es algo que para agradecer. Bueno, no pasó. Hemos mostrado cómo hicimos una proyección anoche sobre la motorhome pegando papeles sobre un costado del motorhome y no pasó. Pero algo que para destacar también... nadie, absolutamente nadie, me dijo ni por acá, ni por ahí, si esto estaba midiendo, si es que el rating, hoy en día...
She was in some sort of weird, strange light, and she was lit up, and everything behind her was dark. It was really cool.
Fantastic. Nebraska, you rocking the house. We really, really appreciate that. But like Vince said, there's a lot more to come, and we got the International Space Station, don't forget. So, Jody, I want to go back. You know, we had to bring in those images, but we were talking about, and you mentioned the stamp. Now, the United States Post Service, they do amazing work.
They do.
But they really outdid themselves this time. Go ahead and finish.
They did. They actually created a special stamp for this event. It's actually a thermochromic stamp, which means that it gets activated by heat, and you're actually looking at it now in your images. This stamp, if you put your thumb into the center, it will actually make the moon surface appear, or any type of heat that you apply to it. It's an amazing stamp, and you know, I got mine yesterday thanks to Dwayne.
And it's thermochromic?
Thermochromic, yes.
Yes. Oh, wow.
It means it gets activated by the heat.
Yeah, heat of your thumb, and I bet you they sold a lot of those stamps.
Oh, they did. They sold out online originally right away, so it was quite a popular one. It's the first time the U.S. has ever used that type of ink.
Okay, so we have seen some pretty cool images. Still got some more to come. Yeah. The diamond has been prominent. Let's go over to social and see how things are going. John.
Thanks, Dwayne. We're continuing to look up here in Charleston, South Carolina, because there are some clouds here, and we're excited. Excitement we want to have here too as well. Just a couple quick interesting things. This is the biggest live stream event ever measured on NASA.gov. The web traffic is accounting for 87% of all federal web traffic, which is pretty amazing, showing that people are really tuning into our broadcast here. As of 1:40 p.m., 4.4 million people climbing were watching this broadcast. So the interest across the country is obvious here, and we're going to continue to show you some amazing live views. This one right here is, again, another photo of the space station taken by Bill Ingalls in Washington, one of our photographers here at NASA. Next thing, I have a video from another photographer, one of our other photographers, as the space station transits. You can see it there. If you're looking closely, you can see the space station transiting the sun during the partial eclipse. Pretty spectacular. Again, that's 250 miles per hour, that space station. And you have to be, 250 miles above the Earth, 17,500 miles per hour. You have to be taking a lot of different shots pretty fast to capture that. So nice job, Joel.
Okay, so let's go to Jefferson City. The moon shadow is continuing to pass over the United States in this remarkable celestial event. Our next stop on the path, as I said, of totality is Jefferson City, Missouri. We're going to hand off to meteorologist Eric Aldrich, who is a professor in atmospheric science at the University of Missouri. He has some special guests to help explain 2 important impacts solar activity can have on humans and the technologies we use. Over to you, Eric.
Okay, thanks a lot. Yeah, we are live in Jefferson City, Missouri. Jefferson City is actually the state capital, and as you can see behind me, there's a lot of people that are here. It's been a whole weekend type of thing, Saturday, Sunday, and of course here on Monday, lots of family-friendly things. There's been corn mazes, there's been 5K runs, there's a lot of good food. Too bad you can't smell the food, but there's a lot of good food that's here as well, and just a very nice weekend. The weather has been perfect. We've had some showers and thunderstorms off to the west all morning. We've had a few high clouds kind of stream on in, but certainly things are looking really good. I am lucky to be joined here by 2 special people that are going to be talking about space weather and just how things work in space. Dr. Janet Kavandi, thank you so much. You are the director of the NASA Glenn Research Center in Cleveland. Right. You're also a 3-time shuttle astronaut.
That's right.
And you're actually from Springfield, Missouri. So welcome home.
Thank you. It's great to be back.
Well, great. Yep. So now, we've been talking a lot about safety, and obviously you don't want to look right up at the sun.
Not without these.
That's right. And so we all have some, so that's good. But what about the astronauts that are up in space? What is there to help keep the astronauts safe from the solar radiation and so on and so forth?
Well, for their eyes, we know that they know that certain windows they should not look out of because there's no protection. Other windows have protection on them that help shield their eyes, but also there's other kinds of radiation like protons that come from the sun, heavier particles that can cause damage to our cells, and we try to
signo. Cualquier cosa te dejo la duda. Soy Aries yo.
¿Vos sos de Aries?
Sí, vamos a...
Estamos ahí cerca, yo soy de Tauro.
Bien.
Me siento la Tana Ferro, ¿viste? ¿Y ustedes de qué signo son? Y me guardo los
primeros del zodíaco. Seguro nos afecta directamente. Y esta fue la primera oportunidad que se transmitió un fenómeno de este tipo a través de Twitter. El mismo Twitter publicó el streaming en vivo para que The Weather Channel, que es uno de los canales
oficiales de la transmisión.
Exactamente, retransmitieron para todo el mundo y no necesitabas estar mirando pendiente la televisión, sino desde el mismo
celular. ¿Cuántas personas en el mundo lo vieron a través de Twitter?
Millones.
What exactly does a space weather woman do?
Well, most people don't realize that the sun actually has its own unique weather that comes from it. And those solar eruptions that come from the sun, they actually hit Earth and cause issues for us. So I actually do a weekly broadcast, weather predictions, just like you do, like a meteorologist, that talks about when these events hit Earth and the types of issues that they cause for things like communications, like GPS and other systems.
Okay, now we're just about 15 seconds away, actually, I believe, from totality.
Put our glasses on.
So we're going to put our glasses on. You can hear the crowd cheering in the background, and it is getting dark.
We're getting close to Bailey Beads. Here we go. We're almost at totality.
And
you can see
here
the
we go.
Almost the diamond ring right there. And there we go. I think we're at totality. So now you can take your glasses off.
That is amazing.
Listen to that. You can actually see the corona a little bit even through the clouds.
That is incredible. Now, Dr. Kavandi, you've been in space. You've seen numerous sunrises and sunsets from the space shuttle. How does this event compare?
Oh, this is completely different than anything I've seen before. I never saw an eclipse. I've seen a partial, but nothing like this. This is really unique and nothing like I saw in space. Space has its really cool visuals, but This is really amazing.
You know, and I'm starting to hear the crickets. They're starting to come on out. Obviously, the street lamps. This is just amazing. Now, I'm also looking up to try to find the Big Dipper and some of the other stars, some of the other planets.
Not for the clouds, likely.
Right.
And I'm like I'm really mesmerized by this. This is a spectacular event. We've had several solar storms that have been launched, and some of them have been launched from the left side of the sun. So we're actually seeing a difference from what the corona looked like in our predictions to what it looks like now. And then on top of that, we have ham radio operators all over the state right now who are making contacts that they haven't been able to make because the upper atmosphere is just all turbulent right now, and it affects the communication signals. So we've got GPS operators and ham radio operators doing a ton of science, and it's just so overwhelming.
This is amazing. Now, my team of atmospheric science researchers from the University of Missouri, they are actually sending up weather balloons here this afternoon to try to figure out, how the weather is changing at certain height levels. And actually, here's a map of the solar radiation throughout the state of Missouri, and you can kind of see how much solar radiation is hitting the surface of the Earth here in Missouri. Just interesting. This is amazing.
It is. You can tell the crowd is just mesmerized. This is so cool. And you can even see the dips in the valleys, as you can see little areas of the sun where it's shining through more.
Right, and those create the Bailey beads that we'll see as we get out of totality, which is coming up here pretty soon.
Right.
Not quite yet, though.
Yeah, I think we come out of totality at 1:15:35 local time, and so we just have a few more seconds of that. Absolutely an amazing event. And again, we're so lucky that some of these high clouds were able to kind of fall apart a little bit so we could experience this.
For us, yes. And I can't believe we can actually see the corona through the clouds.
Good.
Okay, that's the air horn. We're coming out of totality. We're going to have to end up going.
So we need to put our safety eyeglasses back on.
There we go. Put your Bailey beads. There we go. We got to put the glasses back on. Oh my goodness.
So, as you can see, we're coming out of totality here in Jefferson City, Missouri. Ladies, thank you so much for experiencing this with me.
Thank you. Quite an experience. Thank you very much.
Thank you. So, everyone's excited here in Jefferson City, Missouri. The sun's starting to come out a little bit. We're going to go ahead and send it back to Charleston.
We should have stayed.
Thanks, Eric. Yadi, wow.
It's an amazing, I get goosebumps every time I see this. So I cannot imagine how it's going to be, when we actually see it here in South Carolina.
I mean, so Alex, I'm speechless, man. I mean, as a scientist, you got to love this stuff, right?
Oh my God, and it's so great to hear them. I mean, I love hearing an experienced astronaut talk about how overwhelming it is, given the amazing things that she has seen, but also to hear my colleague, Tamitha Scove, who is also a heliophysicist and a space weather expert. I can hear the excitement in her voice. I mean, it's palpable. It's just great.
Okay. So check this out, guys. I mean, I think things are going so smooth. We're going to go to another image right now from Hopkins Girl. Brian Massey out there from Marshall Space Flight Center. What's going on? You got some action there. Hopkinsville. There it is.
That's beautiful. They're getting close.
Now, it's yellow. Is that, we had purple, does that mean something there?
Well, the previous one we saw that was purple was calcium K. It was a blue kind of light. This is actually more of a white light, continuous. Yeah. But the thing to remember is sometimes the different filters you use will change the color just a little bit. But what we're seeing here is really more visible, broader spectrum white light.
Okay. White light.
Let me, John, you got to have some cool stuff on social media.
This is a good question, guys. Mark from Facebook's asking, and this is what really applies right now. When observing the moon at night, I see it proceed from eastern to western horizon, much like the sun does. How come the solar eclipse is traveling from west to east across the U.S.?
Well, again, that's because when we're looking at the moonrise, that's actually because of our location on the Earth and the fact that the Earth is rotating from west to east, the same reason that the sun rises in the east and sets in the west. But the moon itself is moving in the same direction the Earth is rotating, and it's casting that shadow down on the Earth, and that is moving in the direction that both the moon is orbiting and the Earth is rotating. So from west to east.
Okay, so the total eclipse has now passed over half the country. It's currently over Illinois, and I think we're going to have some views coming up shortly. But what I really want to do here, guys, is this has been really incredible. I want to give a shout out to the College of Charleston. Make some noise. Oh, we're loving it here. So now we've got live video coming to us from Hopkinsville, Kentucky. It's a small town that's known for southern hospitality, like Charleston, and it's also a prime spot for viewing this total solar eclipse. Hopkinsville is the city with the longest duration of the total solar eclipse, for a total of 2 minutes and 40 seconds of totality. NASA's Marshall Space Flight Center, Brian Massey, I'm so excited.
Quedan 4 minutos para recibirlo en el sur de Illinois. Y en cuanto esté la imagen, los interrumpimos y vamos directamente al lugar para seguir la trayectoria de este eclipse increíble.
Perfecto.
Que estamos viviendo en la pantalla de TN. Ricardo, Flor, Marina.
Che, perdonen, yo quiero ratificar algo que dijo José Bianco. Juan Pablo II efectivamente murió. Efectivamente no, murió el 2 de abril de 2005 y efectivamente esa semana hubo un eclipse del sol.
Mirá.
Tenía razón José. O sea, acá estábamos viendo que Juan Pablo II había nacido con eclipse solar y murió en la semana de un eclipse solar también. Lo estoy leyendo en la NASA, el 8 hubo un eclipse solar.
Ahí estamos de vuelta en vivo, chicos.
A ver, sí.
En el estadio, que queda poquito, 3 minutos.
Hagamos una cuenta.
Sí, José.
Me dicen ustedes, no sé si yo voy a hacerla en 3 minutos, la voy a hacer realmente en el aire. Pero la chance de que alguien nazca en un eclipse es... Lo hacemos en un ratito porque eso parece ser una fiesta. Mejor me callo, ¿no?
Impresionante, sí, ya lo vamos a hacer. Vos sabés que en la ciudad de Chicago, en 3 minutos no lo ve total, obviamente, pero también tiene su parcialidad, la ciudad de Chicago en 3 minutos, igual que aquí. Bueno, la ciudad de Chicago está en el estado de Illinois, sí, pero más al norte. Todo está fuera de la franja de totalidad. Miren, miren, miren cómo se empieza a hacer de noche. Y lo vamos a volver a vivir, ¿eh? Como lo vivimos hace un ratito, hace 1 hora, exactamente 1 hora, mira. Viendo la hora recuerdo.
Qué bueno.
Qué lástima la nube, la debe de estar odiando esa nube. Ahí está, miren.
Justo está.
Ahí está.
La nube ahí.
Pero se ve igual, ¿eh? Termina y hay un poquitito.
2 minutos
Dale,
nada
listo,
más.
listo, dale.
Y se acelera la oscuridad, miren. Qué belleza, por favor.
Ahí está.
Y el sonido ambiente parece un gol directamente de a ratos. Un minuto y medio. Y estas imágenes que llegan directamente desde la NASA, con el seguimiento que se está haciendo a este eclipse solar total, eclipse americano, el gran eclipse, que realmente está deleitando en estos momentos y en vivo a todos los Estados Unidos, de costa a costa, hasta llegar a la costa este, que lo va a hacer en un ratito nada más. Vivo de vuelta, a ver. Ya casi es de noche, ¿eh?
Sí, se hizo de noche, claro.
Sí, se ven los celulares.
Acá se ve mucho más oscuro que en el otro, ¿eh?
Tremendo.
Bien oscuro se ve esto. ¿Cuánto va a durar, Mati, este?
Acá 2 minutos 50 aproximadamente. Estamos casi llegando al lugar de máxima duración, 2 minutos 55. Escuchen la gente, es increíble. A ver si se oscurece un poco más. Queda un poquitito, me dicen acá los chicos, Edgardo y Ariel. Y ahí se está notando. Miren las luces encendidas, miren ahora.
Impresionante.
La gente se para.
Me encanta la gente, la emoción.
Y queda prácticamente un amanecer. Escuchen. Transmisión que nos llega, insisto. Desde la NASA, que va y viene mostrando el momento en el cual el eclipse cruza el sur de Illinois de manera total, abarcando la ciudad de Carbondale, que es de donde se está produciendo en estos momentos el paso de la totalidad.
Seconds from now and you got a steady shot, George.
Y ahí estamos justamente viéndolo. Siendo las 15:24 y presenciando la noche que acaba de ocurrir y acaba de cruzar por el sur de Illinois. Nashville espera. 15:37. Vamos a ver si tenemos alguna transmisión desde la ciudad de Nashville, el estado de Tennessee, donde también cruzaba por la totalidad. Después va a pasar muy cerquita de Atlanta. Sí, muy cerquita de Atlanta la totalidad. Supera casi el 90% la ciudad de Atlanta en el estado de Georgia. Ya avanzando hacia el sudeste de los Estados Unidos. Todavía le queda más de media hora cruzar, unos 40 minutos cruzar definitivamente a 3.600 kilómetros por hora. Este espectáculo del cual nos juntamos desde bien temprano para transmitirles, inclusive estando en vivo, a todos ustedes. Ricardo, Flor, Marina, Fede.
Bueno, les quiero contar que en este momento, atención, estamos en vivo desde el Central Park de la ciudad de Nueva York con nuestro compañero Diego Poggi. Diego, Nueva York también espera lo suyo.
Así es, ¿cómo le va? Buenas tardes a todos. Estamos en vivo desde el Central Park. Hay muchísima gente. Hace un rato, bueno, esto estaba bastante vacío y de repente todas las líneas de subte, todas las calles, todo el mundo empezó a venir hacia el Central Park. Si quieren, vamos a movernos despacito, les voy a mostrar. La gente vino, está haciendo picnics, por ejemplo. Están todos muy, pero muy tranquilos. Están viendo cómo dentro de un rato, en un par de minutos nada más, se va a poder ver obviamente este eclipse de acá. Estuvimos pasando por todos los estados, es impecable el trabajo, fue una transmisión récord. En YouTube más de 135.000 personas nos han visto alrededor de todo el mundo. Y estos anteojos que están viendo acá, yo no les quiero, no saben lo que fue tratar de conseguir unos.
¿Por qué?
Saben lo que fue tratar de conseguir.
¿Estaban agotados?
Costaron. Estaban agotados, cinco anteojitos como estos, $15. El tema es que no había, y había filas, no les miento, de 5 cuadras para poder conseguir unos anteojos como estos. Hicimos las 5 cuadras, y bueno, todos tenemos estas gafas para, bueno, protegernos.
Diego,
dentro de un rato. Si nosotros miramos, sí, los escucho.
¿Sirve para mirar al sol eso, efectivamente?
Wow, here in Eclipseville, it has definitely lived up to
and now
its
we're
name.
getting that diamond
Here we
ring
go.
on the
We've
way
got
out.
it coming back. The moon is stepping aside
And
from the
now,
sun. It is getting
totality's over.
brighter. Totality has finished here at Hopkinsville. Wow, that was absolutely amazing, Renee. Can you even try to put it in words?
I can. I mean, I just have goosebumps all over my body.
Like, can you even try to put it in words?
I can. I mean, I just have goosebumps all over my body.
Wow, this is amazing. We can see the birds flying around in the
we can
distance.
see the sun starting to come out and it's getting bright again.
This is amazing.
It's really a once-in-a-lifetime opportunity
Yeah,
until the next
definitely.
eclipse
Yeah,
that we'll
exactly.
have only 6 years away. We get to see it again.
Wow, we'll be there.
Yeah.
We will be making
Without
our
a
way.
doubt. I think I'm hooked. I'm an addict.
We have sat in meetings preparing for this for the last 2 or 3 months, and now that it's actually here, it's completely 100% lived up to its billing, and I can't imagine, I can't believe what just happened.
It was just amazing. We were so worried about the weather and the the broadcast and making sure our telescope was set up and everything went smooth, and we just had a blast.
Wow, this has been absolutely amazing. Folks, we have really enjoyed it. It's been a great time here at Hopkinsville, here at Eclipseville, USA. Now time for us to send it back to Clarksville, Tennessee, where our good friend Chris Blair is standing by for their reaction to the eclipse. Chris?
Well, I think he meant Charleston, not Clarksville. So let's bring him back here at Eclipse Central. There's only one Eclipse Central, and it's here in Charleston. Yeah, okay, so the hits just keep on coming through the eyes of NASA. Now, let's continue. Now, these are going to be pre-recorded views from the high-altitude WP-57 aircraft. They soar high above the clouds that could potentially block the views of today's eclipse. And they're chasing the total solar eclipse. They're mid-wing, long-range aircraft used to conduct high-altitude research. So, let's go to these pre-recorded views.
Yeah. Yeah.
Okay. Yeah. What are we seeing here, Alex?
So right now we're looking at these specially fitted cameras. They're on the nose cone of the WB-57, and these are designed to look at the corona, and they're also designed to look at Mercury. They're taking thousands of images every minute and processing this data to give us an extended view, because up there at 50,000 feet, it's 20 to 30 times darker than it is here on the Earth. Because there's a lot less scattered light. So this is a really unique opportunity. As those two planes fly in tandem, they give us about 8 or more minutes of the view of the corona. Now, the other thing they're actually looking at is, because they're so high up, it's very cold, and that allows them to take infrared observations. And in this case, Mercury is very close to the sun, and they can take infrared observations of Mercury to see the temperature change as Mercury is rotating.
That's amazing. So we're going to come back with that. But let's go, now let's go to Clarksville and see what's going on there.
All right, thanks and welcome back. We're excited to highlight some of the student science and the STEM aspect of this solar eclipse. We have several students joining us right now. Would you please tell our audience your name and what school you go to?
My name's Eliza Dellert. I'm from the University of Alabama, Huntsville.
And what club or group are you with?
I'm actually with the Space Harbor Club.
All right, and you guys have been launching balloons all day today. Tell us about the scientific payloads and the instrumentation.
Well, on our first balloon, we had a Geiger counter counting alpha, beta, gamma particles. We also had a pointing payload to get stabilized camera footage along the way. We had some hops from one of our local breweries. And then we, on our second balloon, we had a live streaming payload. So that was cool. That was probably our biggest project, thanks to Alabama Space Grant and National Space Grant. And so we were really excited with all of our experiments. They went really well.
Excellent. Well, we're glad you came here to do this. We appreciate it.
I appreciate it.
Thank you. And so that's University of Alabama in Huntsville. And so we also have...
Tiran por la cabeza.
2 horas después del eclipse pagamos eso.
Hagamos eso, dale.
Tiene mucha razón.
Vamos a ver. Les quiero contar ahora, acaba de pasar algo tremendo.
A ver.
Estamos a menos de 15 minutos, se acaba de nublar. Pero una nube gigante, Bertolotti, solucioname
Pasa rápido, tranquilo.
A ver, tratemos de alumbrar el cielo, no sé, no creo que se vea porque acá no estoy con el equipamiento especial, pero está absolutamente todo nublado, ¿eh?
Diego, quédate quieto, Diego, por favor, así te vemos a vos al menos. Vos nos vas contando.
Nos quedamos quietos. Bueno, se acaba de nublar completamente, no se ve nada. Yo quiero ahora ver si me encuentro algunas caras. Esperen que... vení, Argentina. Vamos a hacer que la Argentina venga acá. ¿Vos ves algo? ¿Se ve algo?
Sí, porque ahí justito está corriendo la nube, pero hasta ahí nomás. Ahora se está viendo, falta un poquitito, un cuarto y estamos.
Pero no había ningún tipo de nube y ahora llegaron todas las nubes. Estas son las cosas que pasan generalmente. El tema es que toda la gente gastó mucha plata en comprar los anteojos, en todo el equipamiento. Se venden binoculares especiales, lentes para las cámaras, lentes para los celulares. Hay un tema con el merchandising y con todo el equipamiento para este eclipse, que ayer fuimos a una de las tiendas más importantes, esta VIH, y había fila para comprarse de todo.
El norteamericano es muy del merchandising.
Yo creo que el país es así, como que marca mucho de comprar y comprar y comprar, y entonces te hacen todo el merchandising.
Tiene razón.
Entonces está bueno.
¿Vos te compraste algo o no?
Lo compramos con Fede juntos porque si no, viste, para
amortiguar gastos.
para amortiguar el gasto. Y sí, ya que estamos acá hay que aprovecharlo.
Está muy bien. Una tristeza, se está nublando y no me quiero poner, no quiero decir nada porque
¿En el
como
parque hay gente con reposera, heladerita, esas cosas?
Sí, mira, hay un montón. Acá hay gente que se vino, no voy a hablar con ellos, pero mira, hay gente con de todo se vino. Hay gente con heladeritas, hay gente con bebidas. Hace un rato había gente con unos parlantes gigantes y acá en el medio del Central Park estaba haciendo una especie de fiesta y la policía los vino a correr porque viste que no está la gente que lo tiene al lado. Se respetan bastante las leyes acá, por lo menos hoy está todo bastante así. Y la verdad que sí, hay muchísima gente y están todos, la verdad que contentos. Otro de los dispositivos, porque hay mucha gente que no quería pagar por esto. Hay muchos dispositivos. Vamos a ver si nos encontramos con uno. Por acá yo había visto, a ver si se lo podemos pedir, a ver si se animan a pedírselo. Hay una caja. Hay gente que no usa estos anteojos y hay una caja. Hay una caja tipo la de cereales. Mira, acá la tengo.
¿Qué, te pones en la cabeza una caja?
No.
Se puede hacer de manera casera.
Esto es así. Mira, es una caja de cereales. Acá la estamos viendo. Tiene papel film y tiene un agujerito muy, pero muy chiquitito. Entonces, ¿qué hace uno? Mira por acá arriba, por donde está el agujero, y ahí va a entrar la sombra. La luz del sol va a entrar y se va a ver una sombra y ahí uno va a poder ver la sombra que proyecta obviamente el sol, que va a ser parcial. Estas son las más baratas y que se hace en casa y que no daña el sol porque no estás mirando directamente.
Claro, es un método indirecto.
Obviamente la sombra.
Es un método indirecto.
Chicos, se está ofreciendo acá, pero no.
¿Periscopio?
Pero
claro, sino simplemente con una hoja de papel y un pequeño punto, una pequeña perforación y una pared a 1 metro aproximadamente de distancia, se ve perfecto. Eso es una manera casera de poderlo. Ya lo vamos entrenando a la gente, la vamos entrenando para el 2019 para que se vaya preparando el material.
Se nubló,
Estamos casi en la hora.
Se nubló y les digo que se acaba de cerrar, por lo menos aquel cielo en el Central Park, de una manera tremenda. Si está un poquito más oscuro, no sé si usted lo puede notar a través de esta cámara, está un poco más oscuro, creo que no es por el sol, es porque se acaba de nublar casi completamente.
Igual, Diego,
y el sol no se ve.
recién vimos por TN cuando pasó por Illinois, se había nublado y se vio igual, Se vio igual.
Sí, no desespere.
Tranquilo.
Sí,
no,
se
chicos,
ve.
Malvina está acá.
No,
igual recuerden yo me pongo los lentes acá y no veo nada.
Chicos, recuerden que es parcial.
Exacto,
¿no, Mati? Por eso la oscuridad no va a ser tan absoluta como el que veíamos recién, que a pesar de la nube se veía muy oscuro. Acá es un 30% que queda todavía iluminado, así que no es para bajonearlo, por supuesto, a Diego, pero vamos a ver si la nube logra desplazarse y los permite disfrutar del
Estamos a 10 minutos.
Bueno, vamos
Chicos,
a hacer una cosa.
claro, necesitamos ir a un corte, ¿no?
Sí, entonces yo no lo voy a nombrar a todos porque es una legión, pero bueno.
Somos un ejército.
Dexter, Matías, Marina, Florencia. Vamos a dar una pausa y enseguida cuando volvamos ya casi estamos con el eclipse en New York City, Nueva York.
Glasses on to look at the sun. The only time that is safe to take out the glasses is when you're all completely, like the moon completely blocks the surface of the sun in totality. As soon as you see that diamond ring effect, that's the timing to actually put back your glasses to look back at that amazing event.
And John, let's get one more social question before we go to the next phase here. We're just having too much fun here.
Starting cold and dark here, too, in Charleston. This is, I think this is pretty obvious by all of us outside right here, but is it safe to be outside during the eclipse as long as you don't look directly at the sun?
Absolutely. There's nothing different. We are just having less sunlight shining down on us, but there's no real difference, and it's absolutely safe to be outside. And we, of course, as long as you're safe, encourage that.
Yeah, go outside and watch this event.
Okay. All right, here we go. So, let's talk about exoplanets. A solar eclipse is a special kind of transit or movement of astronomical body that passes in front of another. And if you've been watching along with us, you know NASA is using today's transit to further study the sun. We use similar transits to study planets outside of our solar system, or as I said, exoplanets, as they pass in front of their distant star.
While a total solar eclipse is a rare opportunity to learn more about our sun, NASA's Kepler mission has been studying distant stars for an eclipse-like event called a planetary transit. Using a space-based telescope, scientists from Ames Research Center have been measuring the changes in the brightness of stars as their planets orbit or transit in front of them. Kepler has confirmed more than 2,500 exoplanets, or planets beyond our solar system. Many of these are similar to Earth in size and distance from their sun. Studies using Kepler data have revealed a vast range of planet types and sizes, and future discoveries could help enable the search for life in the galaxy. Another major effort at NASA Ames to use eclipses to study stars in deep space is called SOFIA, or the Stratospheric Observatory for Infrared Astronomy. SOFIA is a modified Boeing 747 SP aircraft that makes celestial observations in the infrared part of the electromagnetic spectrum. Flying up to 45 absorbs most of the infrared light from space. One example of SOFIA's unique qualities as an airborne observatory occurred when researchers recorded infrared imagery of Pluto as it eclipsed a distant star. What we learn from missions like Kepler and SOFIA could help us to better understand the mysteries of our sun, our galaxy, and our place within it.
All right, thank you. We're here live at the College of Charleston in Charleston, South Carolina, where it is just about time for totality. And I'm here with my colleagues, Dwayne Brown and John Yembrick, and Jari is somewhere, I believe, Carla Vega, and Alex Young. And you can see the crowd behind us. And if you look up in the sky, which I was doing just before we came back here live, we are probably at about 90% totality. And the good news from the weather standpoint is there are some clouds, but I see some breaks in them just off to the south a little bit, and fingers crossed really tight that those breaks are going to move over as we get into totality in just a few minutes. Dwayne, what do you have to say about that?
Well, first of all, I want to thank you for, hey man, we got something. You are the man. You are the man. This is exciting. We've got our glasses. We got our scientist Johnny. Come on, get in here, and Alex here. So we're excited here. The college, make some more noise, College of Charleston. Yeah. We are having a ball here. There's still a lot more here through the eyes of NASA. We got the International Space Station coming up. You don't want to miss it. Now here we go here. Safety glasses on, guys.
Get in there, yeah, but we still got maybe a few more minutes to go till totality, but you can see, look at that, you can see that, yeah.
Wow. Johnny, you know, even with the clouds, we can still see it. It's pretty good, right?
You guys see it?
Yeah. A little bit.
All right. I think we got some break in the clouds. I can see.
We got a couple minutes. We still got about 3.5 minutes left.
Guys, this is amazing, right?
This is amazing.
Through the eyes of NASA. College of Charleston is getting a large selfie with the students and faculty and everyone here.
2.5 minutes left. 2.5 minutes. Dwayne, you've actually seen a total eclipse before.
I have, and it's amazing, and it's spiritual, and it really brings you in step with that. We're just a small pebble on a highway of galactic endlessness.
Does viewing this right now bring you back to that moment several years ago?
It's a little different because I'm here on American soil with you guys here, but it's still breathtaking.
Amazing. Yeah.
You know, Sean, I haven't seen it in Africa and here in the U.S. Doesn't get any better than that, my friend.
No.
Here we go, almost. Here we go, it's coming. Johnny, what is it there? Is it there yet?
No, it's hard to tell. I think that was just the cloud cover. It's getting dark and it's getting cooler too, which is nice.
The temperature has dropped.
Yeah. We're still. I don't think we're quite there yet. We've got some patches of blue just a little ways away. Still just an amazing experience.
I have goosebumps. Like, this is...
Yeah, you've never...
It is safe to remove your glasses and look at the total eclipse. You may remove your glasses.
We've got a minute and a half, right?
Yes.
Totality.
A minute and a half of totality. So we have.
Once again, it is safe to remove your glasses and look at the total eclipse.
That's it. Wow. Put the glasses back on now.
Glasses back on. Yep.
Please replace your glasses. You need to put your glasses back on to view the sun now. Please replace your glasses. You must be wearing your glasses to look at the sun.
I mean, we experienced the temperature drop,
Yeah.
and it was dark. It was dark. 2024.
Yep. Ready for the next one.
Might be in your ear, Sean. Okay, Sean, this is your first, right?
This is my first, but certainly not my last.
How did it feel?
Amazing. You said it yourself, Dwayne. This is amazing. That's the only word to really describe it. You know, even though we had the clouds, it was just an incredible experience. We got to experience the darkness. We got to experience the temperature drop. We got to see it in, you know, kind of moving in and out between the clouds. But most importantly, we got to experience the energy and the enthusiasm that we feel all around us here today.
Well, you know, this team in the city of Charleston will thank you. We had some iffy weather, but you made it happen, man.
Yeah, well, thank you. And you, you know, you don't know the half of it. I've been also monitoring for possible thunderstorms, which we are having. We've been having just up to the north in places like North Charleston, Goose Creek. Luckily, because of a sea breeze pushing the moisture that's been bringing. Allowing these clouds to develop, moisture coming in from the Atlantic. That sea breeze has been pushing those thunderstorms inshore, inland a little bit. So even though we still have some cloud cover here, we have been very lucky not to have any rain or thunderstorms like we had yesterday at this time.
You are really a true meteorologist, my friend. Johnny! Hey, Johnny! Okay, space weather expert extraordinaire. How was it?
It was amazing. Like Sean said, even though that we couldn't see it, you know, consider the solar corona, which, you know, is what I really, really wanted to see. We experienced, you know, the darkness and the change in temperature, and also, I mean, the energy of the students. You know, we even started hugging up because we were like so excited. I mean, it has been an amazing experience. So the next one, you know, 2024.
Hey, Alex. Gotta feel good, man.
This was fantastic, and it was also a big tease for the next one because, man, I want to do this again. I could feel that shadow overhead. I could see the light and the horizon all the way around, feeling the change in the temperatures, even seeing the clouds themselves moving differently as that shadow hit overhead. It was fantastic. It was palpable, man. I could just feel the energy around here. And I want more of this.
Well, let's hear what the country and all of this in Charleston. Let's go to social media. Over to you, John.
Yeah, the reactions across the entire nation have been huge. You know, we have actually, if you're watching at home, some of our streams actually went down only because the fact that, you know, there was just so much traffic on it. Of course, we were broadcasting this all over the country. I want to show up on our some of our graphics here. Some really cool things, photos that we have here. Some crescent-shaped shadows in Seattle, Washington, taken by Logan Johnson. This is a pretty interesting image, as you haven't really seen anywhere else. The next one here is a totality view from Idaho Falls. This is David Cantillo. Just some spectacular images coming in from all over. You know, people are sending us stuff using the various hashtags out there. Eclipse 2017, which is our hashtag, Solar Eclipse 2017, which is trending on Twitter and other places. And of course, we're reading a lot of this stuff coming in too. We're seeing and reading your reactions. Some of it is just really shows the amount of how it really impacts people. And us being here in Charleston, we also saw it get really dark here, get cool breeze coming through. And even though there were some clouds, it was like nothing we've really ever experienced before. And so for those of you who are in the path of totality, I hope the views we're showing you here today have really helped you kind of get the sensation of what we're trying to show. And here's this last one here is a 99.5 near totality nerds here in Boise, Idaho, checking it out. One of our photos there. Everyone is wearing eclipse glasses, and it's you know, we still have a partial eclipse on the East Coast. People are still seeing the sun transit, and so we're it's an exciting time here. I think that I think we have another view here from Bailey Bede's seen from Oregon from one of our photographers. This is a NASA photographer, took this shot right here. I think that's just before the diamond ring pops up, and it's pretty spectacular shot. So I think if we're ready to get going again, I think we have a quick question would like to take.
O en pisos del Empire State o del Rockefeller Center por cuestiones de seguridad, como les decía recién, queríamos transmitir de ahí, y la verdad que de ahí se veía perfecta la ciudad, pero había una especie de niebla. No quiero decir el término equivocado, ahí Mati, por favor, corregime.
Por favor.
Ustedes que saben, son los que realmente saben. Había una especie de niebla. Ya desde tan alto, y no era smog, era como que las nubes estaban bajas.
Puede ser humo, puede ser bruma.
Extraño.
Muy bien, vamos a seguir transmitiendo durante toda la tarde lo que está pasando en los Estados Unidos. El eclipse ya ha cruzado desde el oeste hasta el este. En la ciudad de Nueva York no se pudo ver del todo bien porque estaba muy nublado. Y sigue su curso para perderse en el Atlántico. Nos vamos a una pausa y ya venimos, no te vayas. Hay más, el gran eclipse en TN.
We're watching, this is my second one, but sharing it with you guys, I mean, this is very, very cool and memorable. And 7 years is another one? Is
7 years in the U.S., but we've got one in 2019 in South America.
In Argentina.
So we'll start making reservations already. So this is certainly one for the history books. But we're not done yet. The solar eclipse is traveling over the Atlantic Ocean. So Alex, let me turn to you. How far is it going to go out to the ocean?
It's got another 3,700 miles roughly to travel. It's going to end just off the coast of Africa near Sierra Leone, in that area. But that's also where night begins, day ends and night begins. So we got a ways to go. There's still some more left, and maybe if you're out on a ship, you're going to get to see some more of it too.
Yeah, we have the Coast Guard 5 miles from Charleston.
Oh, well, that sounds pretty good. Well, you know what? I've been talking about this. If you just tuned in, this is NASA Television through the eyes of NASA. We have been bringing you unique images, reaction from all over the country. But now in 30 minutes, we'll be bringing you a view from one place no one else can go, the International Space Station. We'll check in with the astronauts aboard to see how they experience the eclipse from space. Here in Charleston, we will continue to see a partial solar eclipse for about 90 minutes or so. And remember to continue to use safe wearing, viewing, glasses, methods, and everything in between. Safety, safety, safety. Now we're going to my colleague, Karen Fox. Hey, Karen, who's out in the field getting more reaction. There she is.
We have been having a ball out here on the quad at the College of Charleston. Everybody had a great time today. We're going to ask a few questions for the people who were here. Why don't you step over here, young man? Tell me your name.
My name is Josh Petro.
And what year are you?
I'm actually a second year here.
So did you come to Charleston College, the College of Charleston, just to see this eclipse? Like, is that why you chose to matriculate here?
Oh, absolutely. No, to be honest, I love this school, and the eclipse, I've been studying the sky since I was probably 9. Since I could read, I'd take out astronomy books. So this is just once in a lifetime, honestly. It's amazing.
So tell me about it. What did you experience when you watched the eclipse? What did it feel like for you?
It was just like, wow, this is what you read in books. This is the kind of thing that you think, wow, if that happened to me, I don't even know what I'd do. And it happened.
It's fantastic here. So I have one more question. You said you've been studying space since you were young. What are you majoring in now? Are you studying science?
Actually, the plan was to do a double major of astronomy and physics. And hopefully maybe do some of that work myself one day.
Awesome. Come work with NASA. We'll look for you. Thank you so much.
Thank you very much.
All right. Let's find somebody else. You want to come on up? Come on over. Sure. Tell me your name.
Oh, my name is Amanda Anium. I'm a rising junior in the Honors College at CFC. I'm sorry, no, you didn't ask that, but...
But I was going to. That was exactly what I was going to ask. You're like a mind reader. Do you know what my next question's going to be?
How was my experience? It was amazing. I felt a total unity with the world. I did.
That is fantastic. So I have a question. What are you going to do with your eclipse glasses now?
I think maybe as a souvenir for my grandchildren. I think that's what I would do with my glasses.
You're going to be like, let me tell you, kids, this is where I was on August 21st, 2017.
Yeah, exactly. Yeah, she summed it up pretty well.
Fantastic. Thank you so much. We are going to go back to Dwayne Brown, and we'll be back later with more conversations from the college.
Thanks, Karen. It's always good to see the young and those. I see some inspiring scientists out there. Now, let's take a look at the highlights from today's events, and when we return, we'll learn more about how the astronauts viewed today's eclipse. Okay, through the eyes of NASA, only here are we bringing you the International Space Station live. It's traveling at 17,500 miles per hour as it orbits Earth. Now, from NASA's Johnson Space Center, we have Rob Navius in Mission Control. Rob, over to you.
Welcome to Mission Control here in Houston. About 40 minutes ago, the 6 residents of the International Space Station flew over southern Canada, south of Hudson Bay, at an altitude of 252 statute miles, with a very, very unique view of today's solar eclipse. We're going to be talking with the crew in about 18 minutes from now and sharing some of that very, very unique video with you. It was spectacular, I must tell you, and digital still imagery that Randy Bresnik has captured throughout the course of the first 2 of 3 passes the station is making over the eclipse throughout the course of the day today. That has already been posted on social media and will continue to be posted as the day wears on. But we're looking very much forward to talking to the crew and getting their impressions and thoughts as they passed over the eclipse just about 40 minutes or so ago. So we'll be back to you in just a few minutes with the crew of Expedition 52 aboard the International Space Station. For now, back to you in Charleston, Dwayne.
Thank you, Rob. And coming up later in the show, we'll have another unique eclipse view from space. We'll have imagery from NASA's Solar Dynamics Observatory. It's also about to see an eclipse. So, SDO, Solar Dynamics Observatory. Alex, tell us a little bit about SDO.
Well, SDO is one of NASA's heliophysics fleet. It gives us an unprecedented view of the sun. Incredible detail, incredible time and spatial resolution. It shows us 10 different wavelengths of light at the same time, showing us in mostly extreme ultraviolet light, the sun's outer atmosphere, corona and chromosphere, where we can see all of the dynamic phenomena that's happening. It is putting down almost 2 terabytes of data a day, giving us these unbelievable views of solar eruptions, solar prominences, solar flares, and all of the activity on the sun that drives space weather, what Yari spends her days studying.
I mean, it's just an amazing mission because it lets you see in so much higher resolution the images from the sun that you can actually understand the origins of space weather and those solar flares, the corona's mass ejections. I mean, put it in perspective, it's like downloading more than 1 million pictures a day. That's how much data.
SDO, wow, that's incredible. Okay, so we're going to go back to Karen Fox, who has a pretty important person with her. Karen.
All right. Hello, we are back, and I have Mike Massimino with me, a former NASA astronaut who was on the Space Shuttle twice. Hello, Mike.
Hello, Karen. Hello, everyone out there on NASA television. It's good to be back on NASA TV.
We are so glad to have you here. Now tell me, was this your first eclipse?
Yes, this was my first eclipse. I think there's one that passed by my neighborhood in New York on Long Island when I was a kid, because they were telling us not to look up the sky and be careful and all that. I was like 9, I think, when that happened. It was a long time ago. So this is definitely the first total eclipse I've been a part of, and yeah, we'll see. We'll see when I can get to the next one. This was pretty cool, though. I'm glad I got to be.
Let's play hide and seek. We'll come look for you. Annabelle? She's gone.
Annabelle 2, la creación solo en cines.
No, lo que vimos en vivo.
Lo que vimos en vivo, ya me dio.
El cambio de temperatura se empieza a dar, Ricardo, cuando el sol se tapa más del 50%. Ahí ya empieza a haber menos radiación y entonces la temperatura empieza a decaer.
Mira.
Por ejemplo, Buenos Aires en febrero, claro, que tuvo un 70 y pico % aproximadamente, tuvo una caída de 4 grados en ese momento.
Mira qué interesante.
Claro.
Te lo vio muy nítido.
O sea, te alumbra, pero no sentís calor. Y de repente empezás a tener frío, cada vez más frío, cada vez más frío.
Es lo que le pasó a...
Le pasó 10 grados le bajó.
Le bajó 10 grados, claro. Y el tipo estaba con la remerita ahí, se la bancó como...
Se la bancó muy bien.
Escúchame, ¿con qué anticipación se saben que estas cosas van a...
Esto casi 10, 15, 20 años. Porque eso es lo que ha avanzado mucho. La parte de astronomía, con los cálculos, ha avanzado muchísimo. Y fíjate que hoy vamos dando datos de horarios de cada lugar. Y no le erraba ni un segundo.
Es verdad, sí.
Era a tal hora y tal hora pasaba, a tal hora y tiene una precisión.
Bueno, uno de los que dimos tuvo cuenta regresiva.
Claro.
Fue el de Illinois. No,
Sí,
el del estadio.
el del estadio.
El del estadio.
La pasaron bien en el estadio.
Totalmente.
No tuvieron el 100%, pero la pasaron bien. Se disminuyó mucho la luminosidad.
Chicos, más de 16 millones de anteojos repartidos.
16 millones.
Millones de anteojos para que la gente, justamente, claro, los pueda... Así que esto tenemos que pensarlo nosotros, ¿no? Porque, insisto, 2019-2020. 2019 desde Buenos Aires hacia la cordillera, porque es en el atardecer. 2020 en la zona de Viedma, totales los dos, entre 2 y 3 minutos, o sea...
¿De sol?
De sol,
¿De
total,
sol
como que
dos?
vimos.
Lo que acabamos de ver. Aquí.
Exactamente. Dos hay, 2019 y 2020. Es una suerte, no te voy a hacer pero es una suerte...
Un entrenamiento espectacular el que tuvimos hoy. Entonces,
claro,
para
siga a prepararse.
a full. 2019, entonces, y 2020 ya tenemos la cita agendada.
Más allá de cosas intermedias que explicó José, lluvia de estrellas, eclipse de luna y todo que vamos a estar.
Leí por ahí que hay 4 eclipses anuales.
Y 2 de sol y 2 de luna.
¿Siempre?
Siempre.
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 El tema
Algunos
que
son parciales, otros son claro.
No siempre le toca al mundo occidental, toca al mundo oriental. Bueno.
Aparte, fíjate la franjita.
Y no hay quien lo pueda
Lo que es la
controlar.
franjita, ¿no? En el planeta. Si ves la franjita que fue, decís, tengo que tener suerte para que justo me pase exactamente por arriba, porque es una...
How I could get that time off and start saving money to take a road trip, because that was something that I'm addicted to myself now.
That's exactly what I meant. So I thought that seeing partial eclipse before would be almost as good, but I will never miss another one.
All right. Thank you. Congratulations. Thanks for hosting us today. Really appreciate it. Steven, that's the deal here. Just unbelievable. I'm awestruck. Yeah, it was, if we can roll the video that photographer Christian Garcia shot during totality, you can see what it was. It was spectacular. Listen, we are running out of battery power right now. We've got to change some batteries, so we'll be back with you in just a little while, okay?
Thanks.
Awesome!
I'll see you in Texas.
Yeah, right. Let me know. Well, what'd you think?
I know.
When I was trying to do something during it, stop. Yeah, it's just, I was moving, really moving. In Texas, 7 years from now. I know. Where are you from? From Russia? How long have you been?
You gotta look at the shadow, and there's 2 shadows there. The first one makes a shadow, the second one makes a shadow. You gotta line up your shadows, and then up here you see the bright spot. You gotta get that into the lens, and then you get the sun right down there. Alright? Check that. You gotta give it a try. Keep it line up your shadows, bright spot, and put it on the lens.
Thank you for very
Excuse me, but I just tell you about seeing the North Carolina Pipe Talk. Hey, Daddy.
And then line up your shadow. You see the bright spot right there. Get the bright spot into the lens. This one's got actually a clearer picture. And then people around you can see it too. Hold it steady. Hold your breath.
So what's mine? We normally do
That's it. I remember this must be the first one you see it. Right.
awesome thing. I mean, that was incredible. Mark.
Anyways, there's the horseshoe goes all
I mean, it was slowly fading on suddenly, and then it was back. Was that not insane? It was worth the drive, that's for sure. And we couldn't have transported. We had clouds. And it's like,
that right spot is what you have to get through the lens, right? Going onto your computer. Would anyone like to see one? Man, well, let me see how long we have. We need to put. Let me get the mic.
test. So, sounds fine. Does it still sound fine now? Yeah, so I'm not sure what's going on. So this is how
Aboard the International Space Station in the Destiny Laboratory of the complex are 4 of the members of the Expedition 52 crew, NASA flight engineers Peggy Whitson, Jack Fisher, and Randy Bresnik, and flight engineer Paolo Nespoli of the European Space Agency. Thank you all so much for joining us today on this historic day.
Yeah, it's been an exciting day for us to have the opportunity to see the eclipse from here.
Peggy, let's start with you. You were in the cupola with an HD video camera looking out at the limb of the Earth where the shadow appeared, capturing some spectacular video that we're going to replay here in a second. What were your thoughts and impressions as the station flew over the shadow of the Earth?
Well, I'd seen pictures from previous eclipses, and so I think I had underestimated what this would look like. This was much darker than I gave it credit for being. Unfortunately, it was kind of near the limb, near the edge of the Earth from our view, so several hundred miles away. But it still was impressive to be able to see that dark spot as we passed by.
For Randy Bresnik, Randy, you've been looking forward to this event for some time now. Your thoughts and impressions of the eclipse. You also shot digital still imagery of it as well. And what does a solar eclipse do to a human being? What does it do to a human being in terms of understanding our place in the universe?
That's certainly a big question. You look down at the size of the shadow, and we've gotten used to the scope and scale of what the Earth looks like from here, and just understanding how many people will be affected by that. And a friend of mine the other day, mentioned that, and it kind of really came to me, we were actually looking at it, was that just a few hundred years ago, human beings wouldn't have even known that the eclipse was coming. And so here you are looking up, and all of a sudden the sun is disappearing. And what are the thoughts for all of human existence, where everybody's looking up going, the gods must be angry at us, and now we have the ability not only to know it's coming, people are excited about it. We know people that travel to go be under the umbra, and making an event, a celestial event. And for us, being able to witness it from above was just really special, because it represents how far we've come with the technology we have. I mean, look, we're on the International Space Station, where we're doing, more than 250 different experiments, and working with an international team, look at where we're at. And so I look forward to the next time we have a full eclipse. Maybe we'll be taking pictures from a lot farther away.
For Jack Fisher, Jack, it's good to see you this afternoon. You sent a picture very early this morning of this raft of cameras that were laid out in the Destiny Lab, ready to rock and roll to capture every second of this unique event. Was it awesome sauce ×2 for you?
Yes, it was awesome sauce ×2. And Rob, you know, this has been a huge coordination effort. Comrade Randy has been in charge of planning where all of us would be, and a little orchestra of which window, which camera. So he did a great job with that. I was actually supposed to be taking off a window pane or a scratch pane right now, but due to the lighting and how we're going about it, we don't really need to. So I got lucky and got to join all these folks for the PAO event. It was, you know, Peggy said she underestimated it. I definitely did. Just judging from the pictures, that spot was, you know, a lot darker and a lot larger than I thought it would be. And, you know, I kind of was sitting in the Russian segment at the window thinking, you remember snipe hunts? I was like, man, this is kind of like a snipe hunt. I think somebody's pulling a joke on me. And then all of a sudden, this huge black shadow was going across the earth. So it was amazing, and it was cool to see from this vantage point. So absolutely awesome sauce ×3, Rob. 3 chocolate awesome sauce with a side of sun awesome sauce. I don't know. It was awesome, Rob.
For Paulo, we do remember 6 years ago, May of 2011, when you departed the International Space Station on a Soyuz vehicle to come home from your last flight. You took that signature picture of the shuttle Endeavour docked to the station with all of the other international partner components and vehicles linked up. How did today's experience compare with that moment 6 years ago?
Well, 6 years ago, I was kind of alone there on the Soyuz capsule taking pictures. So through the rest of the team, Dmitry Kondraty was flying the Soyuz, and Katie Coleman was actually taking timing and telling me. But it was me with one camera and a video camera and taking picture. Here today we had, as you saw from the photo that Two-Fish Jack sent this morning, we had an armada of equipment. We had multiple places. We were flying back and forth from the station to the cupola Russian segment, up and down, and it was a completely different orchestrated system. I was impressed too by the shadow passing by. I've seen some pictures. And I always, as a kid, I always thought the umbra would be kind of a square, defined square, but it was not. It's kind of a smudge, and this is interesting to actually see this with your own eyes.
Randy, let me go back to you for 1 second to follow up on what Paulo just touched upon. It must have been a photo feeding frenzy on board during those first 2 passes. You all have one more pass to go coming up shortly. Give us a sense of that choreography that your crewmates have explained on board, and was it everybody elbowing each other away from the windows, or how did it all work?
No, certainly everyone has their favorite things that they wanted to do, but we had to divide up the task because we couldn't have everybody doing the same thing. And so we even, took the still shots and said, okay, we're going to shoot this particular type and this particular speed from, this particular person, so we're going to vary it from over here to ensure that we were able to capture the images as best we could to share it with you all. Cupola was a little crowded because we had a bunch of cameras, a bunch of people, and the big thing was to try and not bump the video cameras. Sorry for the one you saw. But, when you see all the video and the pictures, it's not any one person that took them. It's the Expedition 52 crew, to include our Russian crewmates. And so that's where the credit goes, because everybody did their part, not, doing what they wanted to do, which is a definition of teamwork, and that's why we're here.
And Peggy, finally for you, you're less than 2 weeks away from returning to Earth after almost 10 months on the station, having logged more days in space than any American astronaut in history. How did this show today compare with some of the other major milestones you've witnessed and experienced during your 3 long-duration missions?
Well, I think having the privilege of being on 3 different long-duration missions has given me a lot of interesting experiences, and this is just another one to put in the history books for my memory. I really enjoyed seeing this, and I think maybe a little more than I expected to, and so it's just another little piece, another memory, another very special event, another very special day of this fantastic experience of being in space.
And down at Charleston, South Carolina, an old friend and colleague of yours, Mike Massimino, is standing by. He's got a question for you.
Hey, Peggy, comrade, Two Fish, Apollo, it's Mass down here in Charleston. I got to be in the path of totality below all of you today, and it was pretty awesome here, and it made me think of some of the really cool things we see of this, the timing, the cosmic dance of the universe that we see. And for each of you, could you describe something that you've seen? Peggy, you've been up there more than anyone, any other American, and all of you. Something that you've seen that has been up there more than any compares to this, that you only see from space that we can't see on the ground.
Well, I mean, I just feel like the whole experience of being here, of living here, is on a daily basis very special. There's just very special parts of each and every day. I do think this one is very nice. We've seen some incredible auroras lately. I've really enjoyed seeing scientific research getting completed, some really cool research getting completed. And of course, you can't beat the view during a spacewalk, but it's just a piece of this huge puzzle of why being in space is so beautiful.
Back here in Mission Control, for all of you, an amazing day and an amazing opportunity to share a few minutes with the Expedition 52 crew. I'd like to thank Peggy Whitson, Randy Bresnik, Jack Fisher, and Paulo Nespoli for their time today. And for you, Peggy and Jack, and your crewmate Fyodor Yurchikhin, soft landing in your Soyuz on September 3rd. You all be well and fly safe. And with that, Dwayne, we'll toss it back to you at Eclipse Central in Charleston, South Carolina.
Thanks, Rob. Mike, thank you. It's always good to see you.
Thanks for letting me. It's good to be a part of the NASA team still.
Thank you so much for
thanks for having me.
Alex. Thanks a lot. So, Mike, we got you here, man. So, you were here. This isn't your first eclipse here.
My first one, yeah. I never saw one in space, and never saw one on the ground. So this is my first one in space or on the ground was today.
Okay, I know you've been asked the same question, but just how did you feel? I mean, you told that, it's amazing,
It was a really cool, it got a lot of people excited. This is one of the bigger events, maybe the biggest event we've had for a while anyway, and something that everyone can get excited about. Lots of people flocked to the path of totality and as close as they could get, and I just felt there was a lot of excitement about it, which was great. I wish the weather was a little bit better here, though.
Yeah.
We had some clouds in the way, but even with that, it got dark, it got cool. It was, when you see things in space, you don't hear anything, and you're in either your spacesuit, you can feel the warmth of the sun coming or the cool of the darkness as you're going around the planet, and you can see the Terminator between night and day and so on. These reminders of what we're about, what our planet is about, and where we're all space voyagers. Here I was able to feel the coolness, right? And it got really dark. But it was a lot of added sound from all the cheers of the students here at the College of Charleston, so that was kind of fun too. So it was nice to be able to, it was good to be able to share with all these students. I guess the semester hasn't started here yet, because they should be studying pretty soon. Yeah. But they're easing into that, so this is a nice way to welcome them back to school as well.
Mike, it's always good to see you, sir. Thanks for joining the team.
Thank you so much for being here.
Thanks for letting me on. I appreciate it.
Oh, always.
It was great seeing you.
We're having a good time. So, hey, so we're going to throw it back to Karen. Karen, you got some more folks on the yard there.
Yes, I do. I've got John Hakala, who is a professor of physics and astronomy at the College of Charleston. Hello, John.
Hi, nice to see you.
Tell me, is this your first eclipse?
This is my third totality. I saw one in 1972 in the Gaspé Peninsula in Canada and one off the coast of Africa in 1973.
Have you ever done any science during an eclipse, or you're mostly an eclipse watcher?
I I'm mostly an eclipse watcher. I was relatively young, but those two eclipses were what got me into astronomy.
Fantastic. Tell me a little bit about what you did to prepare today for this eclipse with the students.
Well, we had tremendous support from the faculty and staff at the College of Charleston, who put together an event around the eclipse and tied it in with our convocation. So this morning we had a convocation event where we introduced the students, and they're kicking off their 4 years in college with the eclipse. It's probably one of the best ways to, I mean, if there's ever a sign of things to come, this is probably it.
And I saw you out there with some telescopes today. Were people looking through them?
We tried to set those up. I'm not sure how successful they were because of the cloud cover, but we were able to use some indirect pinhole methods, and I walked around one of these devices to students around the yard here, and they seem to enjoy it quite a bit. It's nice when you hear them say, "Cool, can I take a picture?" You know, it's
So life has changed. Can we do a tweet of you and your telescope? Tell me a little more about that with your students. Or were there any of your older students who you knew were out here today, who you knew were excited, and what was their experience like?
So most of our advanced students were working with faculty members from the department, and they went to different sites and locations around the city and the county. So they were covering city parks, state parks, pretty much anywhere that they could get a location. I think we had 16 different sites. So we took the distributed approach. And in fact, I'm here almost by default because everyone else had chosen a place to go. And when the college decided to make a big deal about it, I thought, okay, well, I guess I can suffer and be a good sport. And just to show you what being a good sport means, I had to wear this hat.
You look fantastic. No, it's great. So tell me, what was the craziest question you got that somebody asked you about the eclipse?
So I wouldn't say that it's the craziest thing that I got asked, but I know that a few of the staff folks were telling me that because this coincided with the move-in day, apparently we had some parents who were frustrated with the fact that they were trying to move their kids in, but they had no hotels to stay in because everything was packed. And so they asked some of the staff if they could move the time of the eclipse.
Well, it happened whether or not we wanted it, but I have to agree it's been hard finding a place to stay. I'm sure that Charleston and the college will be happy as things calm down. You get into your year. Tell me just a little bit more. Do you have plans for taking this eclipse into the classroom? I'm curious about whether you think this will kindle excitement for people, maybe get a few new science students.
Absolutely. I mean, I think this is, there are very few opportunities that we have where science comes to the public like this event, and I think NASA's done a tremendous job of advertising this across the country. But as far as it goes here, I mean, we have the advantage now of we had some public lectures by Paul Hertz and Alex Young, and Alex is going to show up in my class tomorrow and kick the year off. So we're very excited about being able to merge this with the beginning of the school year.
That's really fantastic. I know NASA's really excited about hoping that the kinds of information that we've been sharing around the country really gets people excited. As you know, there have been events everywhere. This is our last stop along the way. Tell me, do you already have plans for 2024?
I'd like to say yes, but I need to relax from this one first, I think. Like everyone here, I think this has been, everyone's done a tremendous job putting on a great show and making all the efforts to tie in as many students and the public as possible. But I think we're all ready to take a short breather before we move on.
Well, let me ask you one other question, because you had just told me a little bit. You actually work with NASA data, don't you, on a regular basis, your research? What do you work with?
I study cosmic gamma ray bursts, and I've worked with data from the Compton Observatory, the BATSI satellite. I was a team member on BATSI, and then I've worked with SWIFT data. I have a number of collaborations going with that, and with Fermi data, and I have a number of collaborations going with that.
Fantastic. It's been great talking to you, and we're going to go back to Dwayne Brown. Thank you.
Thanks, Karen. John, I bet you that hat that the professor had on is probably going to be on social media a lot. I can bet that. From coast to coast, we've tracked the solar eclipse over the past 3 hours. Thousands of people along the path of